I'm going to go over standardized distributions and probability and kind of go through some problems step by step that may help you with your active engagement practice activity. So when we look at this, the first thing you want to do is kind of look through and figure out what you have. So immediately it's telling us that we have a population of IQ scores. So population is very important because that means that this information is specifically related to population information. So it's an an average IQ of 100. So that is mu equals 100. And then a standard deviation of 15. That is that lowercase sigma equals 15. So that's all population information. So now it's asking how large a sample is needed to have a standard error that is less than 10. So let's first of all, we're looking at how large a sample. So sample is n. So we don't know. We're wondering how large that's going to be. And then standard error. So standard error is basically the same thing as standard error of the mean, which our equation for that is the population standard deviation over the square root of sample size. Now we want our standard error to be less than 10. So we're basically saying which is less than 10. So we want this to equal less than 10. So in the end, we're saying we want to solve for n. That's ultimately our goal, is to solve for n. So what I do is I would just plug in what you have to the standard error equation. So we have for this standard deviation of the population over the square root of n. Okay, so I have 15, if you remember up here, 15 divided by the square root of n. We don't know what n is because we want to solve for that. And we're saying that it should be less than 10. Now, what I do is I just automatically put this as an equals. So that way you can just solve for it, and then I'll explain to you how you would know whether it would be a greater than or less than symbol. So to solve this, basically, we're going to want to multiply both sides by the denominator in the fraction. So our fraction is 15 divided by the square root of n. So if we were to multiply, so I'm going to erase this right here just so that we can use this side. Okay. If we multiply by the square root of n, that cancels this out here. And then we multiply this side by the square root of n. So then we end up basically with 15 equals 10 square root n. Now, this is multiplying. So 10 times the square root of n is multiplying. To get rid of the 10, we're going to do the opposite. So I'm going to divide both sides by 10. That cancels this out. And then just take your calculator and go 15 divided by 10. Okay? So then basically you have square root of n by itself equals 1.5. But we want to find out what n is. So to get rid of the square root, we need to square both sides. So we're going to square 1.5, and it ends up being 2.25. So now we're talking about people. So instead of saying n equals 3, we just want to use um, the greater than sign. Because if we want our error to be less than 10, our sample size needs to be larger than what we obtained. So n would be greater than 2.25. That's ultimately our answer. Because if you remember, as sample size increases, error decreases. So you're never going to want sample to be less than. You're always going to want your sample to be greater than whatever you calculate. So that's kind of how to get sample size with the information provided. As you notice, we didn't even use the IQ of 100. That's just extra information. Now, the mean of 100 is reported with standard deviation just to make sense of what's going on. It might not be necessary, but you would never report this information without a mean. So let's go to the next example question. So same population information. Now it's asking us to use that above population information and find what is the amount of error between the population mean and sample mean for a sample size of 30. So when we say what is the amount of error, again, error is SEM equals population standard deviation divided by the square root of sample size. Now we have everything we need because we have standard deviation of 15, so 15 divided by, and then we're provided n equals 30, square root of 30. So when we plug that into our calculator, 15 divided by the square root of 30, you should be getting 2.7386. That should be rounded to 2.74. So our answer is 2.74. So on your activity, your answer should be SEM equals 2.74, rounded to the second decimal, which is 4, with our appropriate notation. So that's how statistics should be reported. So basically what this means is if we have a sample of 30, we can expect the error to be around 2.74 points. So that's about, the sample mean will fall somewhere around the population mean, somewhere around 2.74 points is where you would see it falling. And we have is based on the same information from the population, but now we have a sample of 35, and we're asking what is the probability of selecting a sample mean of IQ scores greater than 115. Now this is a little different. So we have our sample size, okay, and it's asking what is the probability. So when we have probability, that's P equals question mark, okay, of selecting a sample mean of IQ scores greater than 115. Well, sample mean is capital M equals 115. Okay, and we have a sample size of 35. So if we are looking for probability, we need to find a z-score. So to get a z-score using means, sample means, we're going to use sample mean minus population mean divided by standard error of the mean. Okay? So we have everything we need to do that. So to plug that in, I'm going to go 115 minus, population mean is 100, divided by, and remember standard error, the mean is the population standard deviation, so that's 15 divided by the square root of sample size, which is 35. So we end up with, so we'll do 115 minus 100 just to kind of get us there. That's 15. Now make sure that those are in the right order, otherwise you'll get a negative. And then if we plug in 15 divided by the square root of 35, we end up with 2.5354. I'm going to round that to 2.54 for that second decimal. So we end up with rounding to the second decimal. Now typically I say keep as many decimals as possible in calculations, but for this example I'm going to round it to the second decimal. So if I do 15 divided by 2.54, then we end up with 5.91, right? Let me double check that. That is a huge z-score, but that's okay. That is okay. Because if you look in your unit normal table, the very, very last z-score is 4, okay? So, I would say use the highest z-score available. So we're going to use this as z equals 4 as it's the highest z-score that our textbook unit normal table gives us, which is just an estimate at least. And that means it says what's the probability of selecting a sample mean of IQ scores greater than 115? Well, if you look at the probability values in the unit normal table for 4, and you're going to look at beyond z in the tell, right? Because 115 is higher than 100. So in that case, we're looking at p equals, in the tell, 0.00003. That is a very, very, very low probability. So this is because you only have a sample of 35 people. So it gives you an idea of how low that probability value is. So I'm just giving you an idea of what you would do if you got a z-score that is way out of the boundaries of what is expected. Hopefully this made sense as far as why I went with the z-score of 4 when the actual z-score was 5.94. It is merely just, like I said, because in your textbook the highest z-score they have is 4. So I would even be okay if you said p is less than, less than 0.0003, because you know that probabilities get lower and lower as they get further out. So either p equals or p is less than. I would accept either one if you get a z-score that falls further than what your table shows you. So let's go with another example that you may see on practice as well as on the exam. So in this case it says a sample of 25 IQ scores. So now we have a sample of 25, and we're dealing with the above population. What is the percentile rank of an average IQ of 105? Now remember, percentile rank is everything below. So this is, it makes more sense sometimes if you draw this. So here we have right down the middle is our population mean of 100, and 105 is just above that. So 105, I'm going to kind of go like this, 105, that's the mean. Okay, percentile rank is this sliver plus everything below. So you know that this entire side is 50%, and then we need to find out what this sliver is and add it to that 50%. So that means we need a z-score. So is what we need is the z-score equation for means. So 105 is our sample mean that we're discussing, minus 100, which is the population mean, divided by, remember the standard deviation is 15 of the population divided by the square root of sample size, 25. Okay, so when we plug that in, I'm going to plug it in real quick, divided by square root of 25. I ended up with 1.666, so I'm going to round it to 2 decimals. 1.67 is our z-score. So that's a positive, remember, because it's on the right-hand side of the mean. When you look up the 1.67 as a z-score, you have 2 different things you can do. You can you can note this area, like this. I'm going to change my pen color so you can see it. This area right here, the mean to z, okay, which the proportion of that is 0.4525, 0.4525, and you can add that to the 50%, which if it was a p-value, it would be 0.50. Okay, if you add those, it's 0.9525. Okay, or you could do something a little different. You could actually look up this area right here, this tail area at 1.67, which is 0.0475. So this area is p equals 0.0475. You could actually subtract that from 1, which would be 100%, right? So you could do, or you could convert it. So let's just do it that way. 100% minus 4.75%, right? Plug that into your calculator, and that equals 95.25. So same thing as you got here, so there's 2 different ways you can do it. Is what you really ultimately want is this entire region, everything below the score of 105. So you have to include what's above the mean as well as the 50% below. So in the end, your answer, because it's asking for percentile rank, is 95%. Usually percentile rank is rounded to a whole number. So because 0.25 is less than 0.50, I would just put it as 95%. So that's the answer that you would put in the practice for active engagement. Okay, let's try another event for the active engagement practice as well as the exam. So again, using the same information, now it's asking what is the average IQ to fall in the 90th percentile with n equals 30. So we have our sample size, we know what percentile rank we are getting, so in actuality, 90th percentile, we would convert Sorry about the sudden dog screaming. Amazon decided to deliver and pound on my door. So just disregard that. So 90% actually converts to P equals 0.90 to help you find that. Now it's talking about what is the average IQ, and we're using a sample size, so we're looking to find the average, m equals what? So that's what we really want to look for to figure this out. Now, the first thing we need is a z-score. So we want to find the z-score at 0.90. And so the 90th percentile at 0.90, you can go ahead and look at the tail, because that is the boundary that basically cuts off the 90th percentile from the top 10 percentile. So look in the tail, the area beyond Z in tail, which is that column C, and find 0.90. Let's see. I'm looking here for it. Oh, sorry, not 0.90, 0.10, because, I'm sorry, let me re-explain that. If we looked for 0.90, we would want to subtract the 50% for it. So that's why I had mentioned 0.10, like 10%, cutting the top 10%. So I want you to make sure you're not going to be able to find in our tables. Now, other tables, I actually have a different table than you guys, so it shows that 90th percentile, but I forgot yours does not show like the combined below the mean and above the mean. So in your case, you're going to want to go, oh, 90th percentile also includes 50%. So you could either subtract the 50% from the 90% or just use that upper region, because either one would be okay. So you could subtract the 90% from 100%, which would be 10%. So, because in actuality, you're looking at this. So all of this here is 90%. This leftover is 10%. So we could look up P equals 0.10 to have the simplest. So in actuality, you are looking at up P equals 0.10 because your tables don't provide the combination of between the mean, the 50% down here, and this area here. Sorry, kind of jumped through that and didn't really explain it well. So you're going to look up 0.10 in the tail, so beyond Z in the tail specifically. And I always just kind of try to find the closest possible. So for me, I'm looking at 0.1003. Okay, so that gives me a Z-score of 1.28. Because it's on this right side of the mean, we know it's positive. So now we have that Z-score of 1.28. So what we need to do is, now we need to find standard error, because we're asking to find proportion using the sample of 30. So we need to find out what our standard error of the mean is. So using the population standard deviation of 15 divided by the square root of 30. So I think we did this once before, but we'll do it again. Plugging that into your calculator, you should get 2.7386. We'll round that to 2.74. So that we can actually plug that in to solve for the mean. Now, similar to the past where we had the raw score equation, now we can use kind of the same basis for a mean score equation. So we can solve for the mean. So we'll use M equals, okay, the population mean plus Z times the standard error of the mean. Now that's basically the same thing as if we were to go Z equals M minus mu over standard error of mean, and we just plugged in what we had, like 2.74 right here, and then the sample mean we wouldn't have, we'd have to solve for that, but the population mean of 100 we'd plug here. I'm sorry, the 2.74 right here would go in the standard error of the mean, and the Z of 1.28 would go right here. And then you'd solve, and it would just be like a little backwards process, but it's the same thing as this. So if you can just recall that equation, you can just plug it in without doing all of the cancellation information. So to solve this, you're going to solve for the sample mean with the population mean plus the z of 1.28, and I'm going to put parentheses around it so it's not so confusing, times the standard error of the mean, which we calculated as 2.74. So the mean at the 100th percentile would be, I'm going to plug this in, so 100 plus 1.28 times 2.74 equals 103. M equals 103.51 because it's actually 0.5072 and we want to round to that second decimal. So this would be your answer on the exam or that active engagement, 103.51, to give you an idea how we would work through that one. And then the last problem is we calculated it right here. Because we used the same sample size in the last one, so we can just look at it and go, oh, our standard error of the mean is 2.74. This is why it's always good for you to do, we'll see, and hopefully walking through it like this will help you. So we have the same population information, and now we're asking what is the average IQ to fall at the bottom 10th percentile for a sample of n equals 30. So the average IQ, again, is we're looking for M, right? And if we look at the bottom 10th percentile, that's P equals 0.10. And this is pretty easy because we're already looking at, okay, here's the mean, but here is the bottom 10th percentile. So we're basically looking for this mean here, because this is 10 percentile here, which is P equals 0.10. So that's in the tail. Now, we already have the standard error of the mean, I think, for a sample of 30. If we go paper and use notations so that it's easy for you to go back and plug things in really quickly without having to recalculate them. So our standard error of the mean is 2.74. Okay? But what we want to do is find the z-score at P equals 0.10. So z equals. So we're going to look in our tables and we're going to find the proportion in the tail because that's where this is located, this area where of the 10th percentile in the bottom is right here. So in the tail, and we're going to look up z in the tail 0.10 because that is 10% when you move the decimal over. So again, that's 1.28, right? Okay, the problem with that is 1.28 was the last one. That was a positive number before. But if you look at this is why sometimes it's best to draw them out. This is below the mean. So our 1.28 in this case is a negative. So be very careful that you're using the right sign depending upon whether it's above the mean or below the mean. So we're going to do the same thing as before, and we are going to use M equals population mean plus the z times the standard error of the mean. So in our case, it's M equals 100 plus, I'm going to put this in parentheses, negative 1.28 times 2.74. So it's very important that you're keeping that negative because this negative turns this positive, this plus sign, it's going to turn that to a negative once you multiply the negatives, this 1.28 times the 2.74, then that's a negative in front of that. So you're actually subtracting your result. So what I'm doing is I'm going to plug in negative 1.28 times 2.74, and that is negative 3.5072. Okay? That should be subtracted from your population mean of 100. So in the end, your sample mean equals 96.49. Now it was 0.4928, but we're going to round to the second decimal again, so this should be your answer. Sample mean equals 96.49. So the bottom 10th percentile for a sample of 30 would be an IQ of 96.49. So hopefully this helped you to prepare for the practice active engagement activity, as well as the problems that you will see on the exam. Please do not hesitate to come to my office hours or email me questions. Thank you.